myself as a business data scientist. So what I do is I apply machine learning and data science to my domain of expertise, which is business and finance, and that's what I do. And today I'm consulting several companies, banks, and some other companies in the different industries, but mostly from the corporate perspective. So glad to be here presenting this webinar kind of tutorial about time series analysis and forecasting, something that I have been doing for quite a long time already. So let's see what we can do. So anything else, Jonathan?
Yeah, no. So I think we can just stay a little, like a minute or two, then we can. In fact, I think we can get started with the
Okay.
webinar. So I think you can get started. The call is being recorded, so we'll share later.
Very nice. This is going to be a kind of hands-on webinar, more or less, where I will be explaining a few concepts as long as we go through some time series analysis and forecasting that we will do. Obviously, this is a very high-level overview about time series, because if you know something about data, you may know that time series has been maybe the first and most antique, oldest techniques that humankind has been trying to anticipate. So we want to understand what is going to happen in the future, more or less. Okay, so so it has been a domain that has been within statistics for quite a long time. So, but is obviously very well evolved, and thanks to the technology evolution and the many different techniques, obviously a lot of things has changed, but fundamentals remains more or less the same. I say more or less because there are many different angles to this. So allow me to share the screen. The series is called, or this webinar series, this webinar tutorial is called Time Series Analysis Fast and Furious. Let's see if we can do it fast, maybe not so furious. Of course, we're going to try to contain ourselves. But let's see if we can do something fast, so we can maybe help to make decisions in a speedy way. Obviously, we can improve as long as we go. So I'm going to share my screen. So I'll share with you very quickly entire screen. Okay, let me know when you can see the screen. I'm actually reading the comments here on the chat, just in case somebody wants to make any question. Do not wait for me until the end of anything. So I like direct interaction with the audience. So stop me anytime you like, anytime you want. Ask me any question, any comments. If you don't agree with me, if you don't like what you see, this is still even very welcome. This is my LinkedIn, just in case you are happy to connect with me. This is my LinkedIn. So if you want to talk about data, that's fine. If you want to talk about football, soccer, or anything like that, I am not very good on that. So if it's about data, this is all good. I'm a Microsoft MVP also. As you can see here, I've been in the MVP program from Microsoft for 5 years. This is an acknowledgement that the Microsoft provides to certain individuals like me for participating in a lot of community events and sharing knowledge, especially about Microsoft products. I've been working with Microsoft products most of my time. My original location where I was granted the award was in Panama. So, however, I've been living in Panama in Central America for many years, but I'm from Spain, and now I'm located in Northern Europe. So you can imagine more or less my hectic life. So, but let's go to the point. So what is a time series analysis? A time series is no more than just a measure along the time. That's all it is. Okay, so we have a measure, a value, a numerical value, and that value is distributed along a timeline. Basically, that's all. It's a time series. So what you are seeing here is the World Bank data. So this is all, it's just public data. Anybody can go there and download it and access it. So it's not hidden data. And as you can see, every item, every measure, okay, is distributed along a timestamp. Let's call it like that, okay? It's not exactly that, but it's, let's call it within a time horizon. Okay, that's a time series. So we need an independent variable, which is time, and we need a measure along the time. Okay, so we can see, for example, this is all about Nigeria. So as you can see, for example, population growth in Nigeria, and this is the growth rate, the annual rate. Total population in Nigeria, 218 million in 2022. But you can see, you can go down up to year 2020. That's impressive that only in 20 years of time, Nigerian population almost double the size. So it's really impressive. So good for you guys, but because in many parts in Europe, in Spain, this is all going down. So we'll see. Anyway, you have also net migration in Nigeria, so you can see positives or negative values. Obviously, negative values. Net migration is the difference between immigration and migration, so flows in, minus out. So when the value is negative, it means there is more people coming in than going out from Nigeria. If I am not mistaken, so I hope I am not mistaken, or it's not the other way around, but you take it, because it's actually the value, the difference between the flowing ins and the flowing outs. We also have the GDP and everything. So the idea here is, okay, we have all this data, which is representing historical data, so we can see what has been the evolution, the trends, the ups and downs, the variances of that measure along the time. Our job as a data scientist or a data analyst is just doing a forecast. It's actually extrapolating. Extrapolating is actually not forecasting, not predicting per se anything. It's just forecasting. Forecasting means that identify what are the historical patterns within the measure along the time and try to extrapolate those patterns forward in time. So we can figure out that if and only if historical conditions remain, which we know that this is not going to happen, but if historical conditions remains, this is what we can expect in the future. Why do we want to know this? Why, for any business, any industry, no matter where you are working or where do you plan to work, why forecasting is important? Well, imagine this following scenario. If you know what you can expect, not what is going to happen. Okay, so what is going to happen is more in the domain of the shamans, wizards, and all these magicians people that they predict the future. They may get it right or wrong, but they predict the future. We don't predict any future. We just estimate, or we just figure out what is the possible future, what's the possible value for anything based off only historical patterns. That's what we do. Why do we want to know that? So this is actually very important and very fundamental, and not many people understand that. If you know what's the trend, imagine that this is all national or global macroeconomical indicators. But imagine that this is all your sales, your company sales, for example, or your purchases, or something like that. Imagine this is all your sales. You have sales like are going up and down sometimes, etc. Well, if you can estimate, you can forecast the trend of your sales in the next coming months, in the next coming future, you can start deciding today what can you do now in order to anticipate what is about to come in the future. For example, if we imagine that this is the annual growth, okay, but imagine that this is all the trends of your sales, your revenue in your business, in your company, okay, and this is what is happening. So up to this point in 2022, Nigeria, imagine that this is total revenue from your company, okay. What is, if everything remains the same from historical data, from the historical conditions, what can we expect the future to be in terms of revenue? Is this going to go up? Is this going to go down? Is this going to be flat? We don't know, okay? But we don't know. But this is important. Why is important? Because if you know today that your trend or the trend of your sales is going to be steady or is going to grow up, you can start today making decisions about perhaps hiring more people, or perhaps loading your investing in your inventories of products or not. So if you anticipate that, well, if nothing changes and everything remains, and we can anticipate that the forecast of my sales are going to be going down, perhaps I'm going to freeze my hiring of new people in my company, or I can prepare or reduce some expenses And you can start making decisions today, not being reactive when things happen in reality. It may happen, it may not happen. This is a forecast, so we cannot predict the future. But at least you can prepare today what is about to come. That's why forecasting and prediction and machine learning and all of that is so important. So we're going to try to do something simple and fast. Not furious, but simple and fast. Okay, so we're going to. So what I did is I just tried to, use something that is related to Nigeria, obviously, where Summit Africa is actually located, and do well. I just selected few options. Downloaded this data, by the way. So I just downloaded this data, prepared the data from all these micro indicators. Well, what will be important for you to, for us to, for example, forecast in terms of national economy? Well, we maybe want to forecast what is going to be the flows of net migration. It's more people coming in or going out from the country. What about for example, the GDP growth or the GDP per capita growth? This is a very important indicator, much more than the GDP itself. Okay, but GDP per capita is very important in any economy. Or the GDP growth, the rates, or maybe the unemployment rates. So how that is going to be? Well, I selected just 3 of them. You can vote which one do we want to use. So I selected, for example, the GDP growth, the rate itself, or the inflation, or the net immigration. There are the 3 options that I just selected just on my choice. But I'm going to give the audience to vote which one of the 3 would you like to predict. So if you want to forecast something, let's tell me here in the chat. Okay, let's see which one do you prefer: GDP, inflation, or net immigration? Which one do you want to start forecasting? So let's see what happens. And we will try to do some forecasts. Okay, so immigration, says James. Immigration, inflation, GDP. Immigration is coming up as a potential winner. Any more suggestions? GDP. So there are 2 immigrations, 1 inflation, 1 GDP. Inflation, 2 inflations, 2 immigration. Okay, Praveen. Inflation. Oh, inflation is winning now. So John, Joshua, Praveen. Okay, there is no duplicated numbers. Okay. Very good. Let's try to predict. Let's try to do some forecasting about the inflation rates. Okay, let's do some forecasting about the inflation rate. After I have cleaned the data and everything, that's ultimately how the data looks like. So we have 2 columns basically, and that's all we need in any time series. We need the year and obviously the measure about the inflation in this particular case that we want to use to do forecasting. Okay, because this is a yearly value, and obviously it's reference over the years. Sorry, I'm not gonna close it. Yeah, there you go. Very good. Okay, so let's open an instance of my notebook. I'm gonna do this from scratch. Okay, I'm gonna do this from scratch, from 0, 0. So I'm happy to share the notebooks afterwards. So I have no problem with that. So let's call it Nigeria inflation forecast. Okay. And to do this, we're going to use right now one framework to do something very fast. Okay. In terms of forecasting, we're going to use the Prophet framework. Prophet is a packaging Prophet Python. There you go. Prophet is a package in Python that was invented or delivered or created by Facebook, today Meta. And you have all the data here. So you have all the documentation, which I encourage you to take a look. There's a lot of things very good. Prophet is very important, very interesting. It has the ups and it has the downs. So not everything is perfect, but it's going to help us to do what we need to do. Okay. So I'm going to leave this here. Let's go back here. So let's open more cells. I'm going to start. Let's start importing our packages. So our basic package is going to be, as usual, NumPy, P, import pandas, and of course we are going to from Prophet. Let's import Prophet with a capital P. Okay. Okay, now everything is imported. We can start using all the functions and the methods from the different packages and libraries. The next thing we need definitely is to import the data. So data, because I'm using my notebook within the same working file of the working directory. All I have to do is just call the data, which is nga net immigration. Okay, so I'm going to save this into a variable called df because it's going to come as a data frame. Obviously, it's using the pandas read CSV method, and all I need is just to call nga inflation CSV. I'm going to tell them that the header is in the first line, and let's take a look. What do we have? So we have yearly data. Okay, 62 years from year 1961 up to 2022, 23, 24 is not published yet, at least in the World Bank database, and this is one single data point per year. That's all we have. Okay, very good. So one of the first things that I suggest you to start doing is exploring what data types do you have in your data frame. So that is very simple. Just using something like info, for example. So, and we can see that the column year, okay, column year, the variable year is an integer, and the nga inflation, okay, is a float or a decimal number, okay. Good, because this is a time series. We may can use, sorry, English is not my first language, but I try to do my best. I hope I can be understood. So one of the first things that that you have to start working with in time series is that your data column, your data type, sorry, associated with the timing should be as a date type. Okay, so let's convert this column, the year column, as a date type. So to do that, we're going to overwrite the data type. So df year, okay, is going to be the same as we're going to call to date time. And what do we want to convert as a date time? Well, the same column itself. Okay, so like this. Okay, once we have it, if we check again the data frame type or info, it doesn't really matter. We can see now the before and the after. Okay, now Python knows that this value here is a year, is the time attribute for a date type. Okay, because this is now a date type. Okay, a date time type in particular. We can now start doing some kind of manipulation and preparation of our data frame. Something that I always advise is never use your raw data. Never use your raw data to do any kind of forecast transformation, analysis, or anything. Always preserve your raw data because this is your golden truth, and from there we can start creating what we need, or the type or the data frame that we need to start working with it. Okay, so let's create a new data frame with the attributes that we need. Okay, so I'm going to instantiate a data frame that is going to call, for example, TSDF. It stands for time series data frame, and that is going to be an empty data frame, so an empty pandas data frame. Now, in this empty data frame, we're going to add a new column that we are going to call date, but date is going to be renamed as DS, okay? Date series. I'll show you, I'll explain you in a minute why do we need to rename it as DS. So this data frame, sorry, this column new is going to be date range. Don't worry if you don't understand this, but I'll show you what are we doing and why. Let's start. Date range is going to start. We're going to start on the first year, but now we're going to put it in the date format. So which is 1961. 01, 01. Okay. We're going to use periods. It's going to be the same as the length of df, which is this data frame that we loaded. Okay, the length, 61 rows. Okay, 60. So actually 62 rows from 0 to 61 is what we need in the period. So okay, you want to start. I'm creating a column that is a date range. Okay, we want to start on January 1st, 1961. Okay, how many items do you want? Well, I don't know. What I know is this range. Obviously, I know that I need 62, but I can hard code it, but I prefer to make it dynamically. So just in case this new data gets updated, everything will be automatically updated as well. Okay, so that's why I put this. And the third parameter, super important, is okay, how frequent do you want this data to be happening in every single row? Well, this is yearly data. This is yearly data. So I need to tell them that every line, okay, is a new year. The gap between one line and the next one is 1 year. So therefore, the frequency is going to be year. Okay, that's the first column. That's the first column that I'm creating over the data frame TSDF. Second column. The second column is going to be the measure. Okay, and the measure I'm going to call it, which is, the measure is actually called NGA inflation. Okay, but we are going to call it for now Y. And the reason I'll explain you in a minute. So this I'm going to just copy and bring the NGA inflation. So I am mirroring I am copying basically from the data frame NGA inflation. So all these values that are here, all of these are here. So I want this all stored into a new column called Y into TS data frame. Okay, so let's execute this. And if I haven't made any mistake, which I have done, which is here, it happens all the time, to me at least. Okay, let's check what TSDF has. Now I have two beautiful columns. One, the DS, the timestamp, and as you can see, because it's at the end of every year, so it's a yearly series. Sorry, it's a yearly series. So every line is a year, is 1 new year, but now it's keeping the format as a full date ISO standard. Okay, and the year is the same. Sorry, the Y, the measure, the inflation is the same. The reason why I didn't use date and inflation as those new columns is because the profit environment, the profit framework requires, is part of the documentation. That's why I share the documentation here. You can go here. The documentation says that profit requires for them to identify which column is a date and which column is the measure, that the date is always going to call DS. Okay, and the measure is always going to call Y. That's the only reason why we rename it this. And this is into a new data frame that is nothing to do with our original data frame that is always going to be kept separately. Okay. Okay. As you can see, I talk too much. Let's do some testing. Let's check, for example, how our inflation looks like. Very quick plot, just to check how that looks like. Come on, you can do it. Because I'm sharing screen, normally it takes a bit longer to execute. Okay, so it seems like in 1981, 92, more or less, you have a huge spike in inflation. Then it went down, then you have a peak, and etc. More or less, it's stable around, as we can see in the last few years, somewhere between 10, 11, 7, more or less, approximately. Okay, that's more or less what the official numbers says. We know what the official numbers and what. Let's call it that. I always get frustrated with the official information from governments. Anyway, now let's do the forecast. So to do the forecast, let's create a new column. So actually, this one here. I'm going to put it here. Let's start doing performing forecast. Performing forecast. Okay. So to perform the forecast, the first thing we need to do is create or instantiate the algorithm which is going to be applicable against my time series data. So let's instantiate it and go and store it into a variable called profit. Okay, so this profit with capital P was what we brought from the package profit. Okay, and just instantiating the algorithm and stored it into a new variable. So this now is this variable contains many classes, methods, and everything. That's very important. But this variable actually is the algorithm, but this algorithm is now empty. We need to start doing things with the algorithm. And this is exactly what we're going to do. So in order to train or let the algorithm to be adjusted to the data, so what we're going to do is pass this data frame that contains the 2 columns required by profits, okay, with the method fit from the profit, the algorithm, okay, here, and let's call it TSDF. And now the algorithm already was trained with data. This data was those he knows that this is the measure that we want to forecast, and this is the timestamp, and he already identified that this is yearly data points. Okay, now the algorithm is ready to start doing forecasting. Okay, so let's now prepare the future data frame. So the future data frame, let's call it the algorithm itself that has been trained, and make future data frame. And in here we have several parameters. This is very important. The first parameter is the periods. How many periods forward? Do we want to forecast? Okay, we have 62 years of history here. Let's forecast, for example, the next 5 years. Okay, next 5 years. Okay, so something prudent. So we have to tell them, although, okay, how frequent, how many iterations is on every timestamp? Well, every iteration is very simple. It's 1 year. So from this observation to this observation is 1 year, the same as the next one and the same as the next one. So we need to tell the algorithm, okay, the frequency of the algorithm is yearly frequency. And we want to include the history, which is already by default, but let's call it just in case. So we can see also not only just the few 5 forward, but also the previous 60 values. Okay, now that we have trained, okay, the algorithm and told the algorithm, okay, now that I have trained you with this data, when I say train, it means the algorithm is checking every single variation, the tendency, cyclicity, stationality, everything. So this is what happens in this first portion. The second portion is, okay, now that you know, okay, how is the shape of this chart? I want to forecast 5 periods forward, okay, from the last period, which is 2022. So we're going to forecast 23, 24, 25, 26, and 27. Okay, we're going to forecast this forward. Okay, and I want this to be also yearly data. So every of the 5 points forward is going to be one yearly data. Now, let's do the forecast. So inflation forecast. Inflation forecast is going to be the same as the algorithm that has been already trained, and now we are going to use the predict method, okay, the predict method over the future, which is the value that contains, or the data frame that contains all these values to be forecasted. So future, okay. Let's see what this inflation forecast contains, okay. So inflation forecast, if you take a look, we have our first value, which is 1961, and now you can see the last value contains, it goes up to 2027. So the last 5 values that we see here, 23, 24, 25, 26, and 27. Okay, where is the forecast? Because this is the timestamp. This is the column timestamp. Where is the Y column here? There is no Y column here. Yes, there is. It's called Y hat. Okay, this contains the forecast. Okay, this is the forecast for the next 5 years. So not good news for Nigeria. Not good news. According to this forecast, I'm not saying that this is what is going to happen. And what you're seeing here is the values that this algorithm produces, okay, if all historical conditions remains. That's what it says, okay? This forecast, these values can be higher or lower. Yes, but this is not a crystal ball, okay? So let's do now some plotting, because this is important. So let's do some plotting. Let's select just a few items important for our plotting. Okay, so we have a method that is called, let's call it in the first chart. So let's call the algorithm. Okay, we have a method called plot, and plot, we're going to use the inflation forecast. Okay, you will see inflation forecast. So if I execute this, okay, this series is normalized. This is the outlier that we have in 2080 something, sorry, 1992, 93, more or less. This is the outlier. But this band, this is called the interval of confidence. So this is just the interval of variance between the maximum and the minimum possible values. Okay, so it can go from 0 or even minus something, because there are some negative values over here. So it has been some deflection here. But you also have the possibility to go up to 50%. Okay, inflation, which is super, super high. So we can see this blue line here is the trend of the inflation. Okay, so we can also do something interesting that that Prophet contains, which is plotting the components, which is in a chart 2, for example, we are going to store, call it Prophet, and there is a plot components of inflation forecast. So the overall trend is going down. That's what the trend of the chart. This overall trend is going down, obviously, because it's very highly influenced for this outlier. This one also, but this is going down. And the seasonality per month. Okay, so every month of all the 62 years, this is how it looks like. So we have a peak in February and normally a peak in December. This is where the highest peaks in terms of stationality and seasonalities for the inflation. This gives a lot of good insights for analysis on this kind of data. So now we know an idea. Now we have a clear idea, more or less, on what to expect in terms of forecasting the inflation for Nigeria. Okay, let's do something now that we have Prophet instantiated. So we have done this in 10 minutes. Okay, as I can see, and as you can see, we only require, after loading the data, we required 1, 2, 3, 4 lines of code, and then you have a forecast. 4 lines of code, and then plotting 1 and plotting 2. 7 lines of code. It's not bad, right? Only 7 lines of code, and we have a forecast. At least we have something to start working with. Let's do something maybe a little bit more, daily seasonality or daily time series based on more financial data. Well, I had a little hard time finding financial data in Nigeria, but I found in Yahoo Finance, there is a global fund, an investment fund that actually is dedicated only to invest in Nigerian securities. Okay. So sorry, I'm missing the question here. Justice. What if we want to get the forecast that is every 3 months, say CPI? What will be the parameter of the frequency? Very simple. That's a great question, in fact. So all you have to do, obviously, after reading the documentation, you will find that all you have to do is change this frequency parameter from Y to capital M. That's all you need to do, okay? If it's a daily season, okay, or daily time series, all you have to do is change it for a capital D. That's all you have to do, okay? James, the forecast looks nice to me. Okay, yes, this line here is actually the de-stationalized trend for the entire series. So more or less, you can call it, this is the average value for all the time series. And obviously, those values at the very end that has no black dot points here, those black dot points is the actual value. So this blue line over here is the average forecast forward in the time. So, okay, which is, in fact, those value of the y hat that you have here. Okay, that's the forecast. Okay, just 7 lines of code. That's all we have. Okay, let's. It is possible to plot moving average. Not using profit, but you have a moving average that you can use just with a simple pandas method. So it's very simple. Or you can use NumPy if you want. Not moving average with profit itself. Okay, but you can actually add it here. To this data frame that contains all the data, including the historical data, so from 1961. Okay, so but it has to be separate. Okay, as I said, let's do something. Let's change it. Let's change to another type of data, which is daily data type. So if we go to the summary. Thank you again. Just keep posting your question. Don't worry. So let's take a look at how this found looks like. Actually, really bad, unfortunately. So all the investments made by the found, this is what we're saying is actually the value of the share of that found. Okay, so but it's actually clearly downtrending. It has some ups and downs and everything, but clearly downtrending. We see more historical data. Again, we have the ups and downs, etc. More or less, it was stable during certain years from during pandemic, more or less stable, which was not bad at all. And now is falling drastically down from this point in June 2023. Up to date, it has been falling down. It could be many reasons. So it's just not necessarily a very bad management of the found. Okay, so let's try to understand how just bringing data from this stock share from this found. Okay, how much can we estimate or predict or forecast the value of the share will be? But we have some considerations. Okay. This is financial data, okay? That's why I wanted to use this. Imagine that instead of the value of the share is actually your inventory or your sales or your revenue from your company, or how many customers are hitting your website, for example. If you want to make a forecast about how much is going to be the demand of your compute power in your, I mean, there are many things, many scenarios where you can do that. What we have here is all the values for the share. We have the open of the day, the high value of the day, the low value of the day for the share, the close, and the adjusted close. And obviously, how many shares were traded that day? Not bad. 18,000, 6,000, 10,000. Okay, not bad. Okay, it was one day there was 129,000 shares. Oh, that's a great day. Anyway, so let's do a forecast using this data. And the forecast that we're going to use is using the close value. The close of the day is usually the official value of the share per day, okay? But a couple of caveats, okay? One is the time series is referenced by day, okay? So it's a day's time series, but not any day. It's a business day, because this is a financial market, works only from Monday through Friday. That's it. Okay, except obviously the holiday seasons. Very good. Well, let's see how we can overcome that, because if it's a time series, we need all data there, including Saturdays and Sundays, or non-business days, but obviously will be value 0 or the same value. I don't know. So we need to fill down all the. Imagine filling all that out for 2 years. You need to include all those data into your data frame. So well, let's actually select only the last 2 years. Okay, and I'm not going to download anything. I'm just going to go to the website here and directly read all this data from the website into my Jupyter Notebook instance. So what I'm going to do, instead of clicking download, I'm going to right-click on it. I'm going to copy the link. Okay, this is going to produce a CSV file. I'm going to here. And let's go to the found is called, what is called MSCI. Okay, MSCI. Let's call it MSCI. MSCI. Okay, MSCI is going to be read CSV. I just pasted the URL MSCI. Let's see what was stored there. And as we can see, we have the data. Okay, those 2 days, for any reason, we don't have data yet. Okay, maybe this hasn't been published or something. We don't know. We don't care. But let's clean this up. We have all the columns: date, open, high, low, close, etc., etc., etc. Okay. Well, let's actually filter this data. So I'm going to filter this data from, I want all the rows from 0 to the row 498, index 498. Actually, I need to add the ilog method. Okay, and I want all the columns. Okay, so now I do this, and I check MSCI. And as we can see, oh, wait a second. MSCI. There you go. There you go. Now we have all the data present. Okay, no blank values, no nulls, no empty values. Now let's check the close value. Okay, and start doing the same exercise, a time series for this. So let's actually, as I said, keep always. Praveen, the stock market does it all the time, and all the analysts. When I was a trader in the stock market, we spend our lives, days and nights, just thinking about forecasting. That's all we have to do. So let's do, again, our time series data frame. I'm going to call it just TS, just to avoid any confusion with our inflation forecast, or how do we call it? TFDF. Okay, I'm going to call it just TS. Okay, when you're typing so much, you normally use short names. Anyway, TFs is going to be, again, an empty data frame, and this data frame will contain 2 columns. The first column is going to be DS, okay, and DS is going to be date range, where we are going to start. Now let's do something different. We need to start on 04/04/2022. So 04/04/2022. Yeah. This is why I put it on the same format. I don't remember right now. No, I use the ISO. ISO is the right one. Okay. So it's going to be 2022 04/04. Okay. Now, we need also, sorry. We need also, how many periods do we want? The same of the MSCI data frame. And now here is the interesting one. The frequency is not going to be day, no, because we only have business days here. So the frequency is going to be business days, which is called B. B stands for, obviously, business days, but it's, he knows, Pandas, or data frame, Pandas knows that now what we want is every day within Monday through Friday. We're going to exclude Saturdays and Sundays. So the second column, our Y column, is going to be as simple as MSCI data for close. That's what we need. Let's check what do we have. And this is our value. So we have the day stamps from 04/04/2022 until February 28th. No, actually, no. I think it's missing some values like years or something. Well, I can fix this. Let's fix this just to do it right. So it's going to be MSCY. Let's fix this. And now we have it right. There you go. There you go. Why to reinvent the wheel when it's already invented? I always do. Anyway, let's make sure that our data types are correct. Info. We need to fix this DS. It must be a data. Well, anyway, maybe works with Prophet. Maybe works as long as you can identify this as a date timestamp. Let's see if it works. I'm testing here. I'm learning here with you. Believe me, I'm not doing nothing yet. Anyway, let's call it now a new. We cannot use the same algorithm here, Prophet, because it's already used. Let's instantiate a new one, and let's call it, for example, model. A model is going to be Prophet, which is already instantiated and imported into our. Here you go. And now from model, we are going to fit it. We are going to fit it into our TS data frame. Okay, and now the model or the new Prophet model is already fitted. Now let's make for example, the TS future, and this is going to be model make future data frame. And in here we need how many periods do we want? So let's check it's business days. So 20 days is going to be 4 weeks, 4 business weeks. So 20 days. So the frequency are business days because we don't want Saturdays and Sundays, and include history is already true, so we don't need to call it, so we don't need to invoke it. Okay, and now we're going to actually time series forecast. We're going to model predict TS future. It looks like I haven't made any mistake. So TS underscore forecast. There you go. Now we have it. So we're forecasting up to 2024 April 24th. Okay, 24th of April, and these are the values forecasted. Okay, so let's plot it. Let's plot it. So model plot actually in a chart. So we have chart 2 and another plot ESDF. No, STS forecast. Okay. That's how it looks like, and it doesn't look like very well. And as you can see, it looks like trending down. Okay, clearly. And this blue bands is the higher and the lower possible value for each day. So that's actually, in fact, if you are interested to know, so this value, so this is the forecast, but we also have the, is this the trend, the upper and the lower band. Y hat lower is the lower side of the blue band, and Y hat upper is actually the upper side of the blue band here. This is the range, the most probable range of when the forecast is going to be calculated according to the variance of the time series historically. Okay, the same for the same for the components, but there is also a very nice option that we can bring. There is a component with Plotly. Yeah, Prophet has yes, here it is. From Prophet has also from Prophet. Let's see if I remember. Yes, it's plot. Yes, Prophet plot. Correct. Let's import 2 dynamic plotly. Yeah, and plot components Plotly. There you go. Let's do this because this is going to be nicer. So plot model. No. That was before. Plotly, and we need, here you go. There you go. I need the model and the forecast. Okay, so that is going to be model, and I need the time series forecast. And this produces a more interactive forecast, where if you hover over the chart, it gives you the date. So, and we can also slice down, zoom in and zoom out. Okay, I can actually slice down and focus. This is all the three values, and focus exactly on how the trend for the forecast is going to be over the next 30 days. So this is the simplified view. This is the expanded view. So if you want to just auto-scale it, click on here and do the same. Now that we have daily data, we can do the same, but now using the plot components dynamically, and we need the model, and we need also the TS forecast. And this will produce also the trend month by month, and what happened, or what is the usual trends accumulated by daily, the day of the week. Obviously, we don't have Sundays and Saturdays, so the values are zeros or nulls, so you can ignore this. But we can see that Mondays, Wednesdays are the days more active in this value, in this share. Okay, so that gives you extra insights. And again, you can hover over the values and see what's the value weekly on the day of the week for this analysis. Okay, so this is the Prophet method. Any questions so far? Blue bands are like no. Blue bands, Justice, is not the Bollinger Bands. The blue bands is the interval of confidence. Bollinger Bands is another thing. It's a standard deviation rate over the measure that you're trying to do. James, what is the root mean square error of the forecast? Very nice question. Very nice question. I didn't want to show this here with Prophet. That's why I wanted to make another demo, but using another framework that I personally like very, very much, which is PyCaret, where we can see not only the root mean square error, but also the mapper, the MI, and many, many other things. But not only one model, many models at the same time. This is fantastic. So let me show you how to do this very, very fast. Again, another seven lines of code plus the extra 2 for the chart, 9 lines of code, and you have an entire end-to-end forecasting project. Not bad, not bad. Nine lines of code. Let's close this, okay, and let's create a new one. Believe me, this one is going to be fast and furious, okay? So we don't need this. So let's open a new one. Let's actually use the same values here for the font. Sorry, because I want you to see how PyCaret works in terms of forecasting, which is fantastic. Okay, so this is going to be Nigeria. Nigeria MSCY forecast PyCaret. Okay, import numpy. I'm going to be faster right now because I know I'm reaching the hour right now. So pandas as PD and what happens? Come on. What I have done here? Oh, come on. How can I escape from the full screen? I have hit a button here.
I think the ES, okay, F11.
F11, right? Oh, there you go. Thank you. Thank you. Sorry about that. Thank you, my friend. Pandas from PyCaret time series import all. While this is running, let's go pandas read CSV. Let's bring the URL from here. Let's actually clean this and call it until March 28. So copy link. Oh, come on, you can do it. Does Facebook Prophet has hyperparameters that you can tweak and probably control the results? It has some parameters, but it doesn't let you control many things. I actually encourage you to go to the documentation. Yeah, yes, here it is. And in here, you have a bunch of stuff. Something that very interesting that Prophet has. Obviously, you can control certain parameters, not all of it. And as you can see, the column has to be renamed like this, etc. But something very important and very interesting that that Prophet has is you can actually control and include many things about seasonality, deseasonality, multiple seasonality, for example, and even combine different timestamp data. Like, for example, imagine that you have a column that is daily reference, and you have another column that is quarterly reference. You can also combine everything into one thing, and even more important than that, for business data, you can also call the what is that? Let me see if I can have it. The holidays. So it contains all the holidays already determined into the package, so you can call the holiday season for whatever country, and those holidays will be applicable, will be applied, directly onto the time series data frame itself. So the algorithm know that he can expect those dates to be null or blank or extreme values, and it's going to maybe ignore it or treat it separately. So that is very interesting. So. And it's very good. Prophet is very good for short-term forecasting. Don't expect to do very long forecasting, like give me the 6 months or something else. It's very good for short forecasting, 1 month, 2 months, depending on how much historical data you have, obviously. But it's always good to combine it with other type of analysis. So you can combine longer trends with short period of very highly accurate prediction. Okay, so that's what Forecast said. So, okay, this loaded. Now we have our data here. So in our data, let's select, for example, the time series, and this is going to be the same as DF, and we only need. I actually need the column closed because I can only work with a vector instead of the entire data frame. That's actually very cool from PyCaret. So the time series, let's say model. Let's instantiate the time series experiment. Okay, so now over the model, I can set up the entire thing. So I'm going to call it. The data is going to be TS session ID. This is going to control the randomness. It's like setting the seed. Okay, my standard is 100. You can use obviously any other standard. My forecast horizon to validate the forecast is going to be 4 days, 4 periods. Okay, so 4 days, and the seasonal period. Okay, seasonal period stands for the frequency. So this data is business date. So I need to tell the algorithm that what you're going to see in this forecast, in this vector, in this line, so in the column close, the iteration is every 5 items. So from Monday through Friday, is going to be an iteration that is called a business day. So let's set up the model or the algorithm, and we will start training all the models at once, and we can see the results. Okay. There you go. So this is the last 4 values that we're going to use to validate the last 4 values of the training. Okay, so we're splitting the entire data frame between training and test set. Okay, and now there is PyCaret has a phenomenal function method that is called compare models. like this. And see, now we can see every single metric of all the models running all at once. This is going to take a couple of minutes because it's training all the models at once against the same time series. And I'll show you also a couple of things interesting about, there you go. We can see now the root mean square error, the mean average square error. This one is very important. This one is very important in time series. R square is not the best method or the best metric to evaluate a model in time series because it's a sequential one. So as you can see, it's processing. This is going to take a couple of minutes because there are many models coming at once, but I want you to see it just in case you haven't seen it in action, because this is really nice. And I'll show you how to create a model and how to do a forecast, how to plot it, etc. It's a lot simpler than what you think. Now we have how many? After importing the value, we have 1 line of code, 2 lines of code, 3 lines of code. That's all we have with PyCaret. And with 3 lines of code, look, we're just training. Now we have 5 models, okay? Profit is just 1. Combined, very powerful, it's true. But you can see how many models are coming from PyCaret. Okay, it's running. Come on. Take a look. How many models are coming all together at once? And you can compare side by side all of them. You have all the metrics there. And not only that, it's going to tell you which one is the best and why, which is very important. Look how many models. All of them are being trained all at the same time with the same data. And what is very important when you're training multiple models is it is extremely important that all of them comes with the same standard parameters. Because it's very usual that if you change one little thing in the settings of the algorithm, your model, you're thinking that you're using the same parameter, the same scenario for the algorithms, but they're not. They're trained in a different way, so may not be the same result. So you're using the same baseline parameters to train all these bunch of models at once. Look at this, and I haven't finished. You can see how many models you have there. Okay, so maybe many people think, oh, ARIMA is the best model. Yeah, well, no, not here. Okay, you can see the masse here. We want the lowest masse. In this case, Theta Forecaster or Haber, the Haber is very good as a regressor. When you have extreme data, extreme values, it's very good. You can ignore it. AutoArima is in the top 4. That's great, but you can see that it's highlighting which one has the best parameters. Okay, which one has the best parameters. Sometimes I select my or mappe. Masse contains or is a measure, is the difference between masse and my is masse is actually the square error of the quadratic my. Okay, well, I hope that you understand. So that means that masse actually measures, in this case, or considers the extreme values, how much that affect the forecast. But also my is a very good indicator. In any case, Theta, this model, this regressor, the Theta Forecaster, is actually the best model for this time series, and we're using the same data as we did with Profit. Okay, let's create the model. Let's create the model Theta. So let's call it Theta, and in Theta there is we call it model. Yes, model. There is a method called create model, and all we need is invoke the Theta. The Theta model. Okay. This Theta model is this value here. That's all. Okay. And he is running. And again, now this model, this variable contains the model. If you want to take a look, this is nothing more than this is the forecaster. Okay. That's the forecaster, the Theta forecaster. Now let's run model. Let's plot the model. Let's plot the model Theta. And the plot type that we're going to use is going to be in sample. I'm 11 minutes over the hour. Okay. You can see the blue line. The blue line is the actual value. This is the blue line. We can see the orange line. The orange line is the value from the model. Obviously, there is a gap. Okay. But the model is obviously training and is learning as long as the time series goes along. So we can see how that gap between the forecast or the result from the model forecast and the actual value is getting closer and closer and closer all the time. Now, the beauty of this, we can actually drill down and see how close is the value from the forecast model against the blue line, which is the actual value. And we can see, okay, how close are in the last few points. So that means that this model is learning, okay, along all the historical data of the model. Very good. Let's start doing now forecasting. Okay, so let's actually finalize the model. So finalize the model. And let's insert it into a new variable. Let's call theta final and finalize the model. And the model that I want to finalize is the model that I save here, the model theta. Okay. So theta. Now, finalizing the model, it means that he is going to be training with all the data, including these 4 data points at the end. Yep. What happens? Okay, global. Okay, I see. Model dot final. There you go. Again, the model final, if you want. There you go. And this is the entire pipeline for the forecasting model. This is the entire pipeline. Okay, it's creating a pipeline behind the scene. Yeah, let's, now that we have a model finalized, finalized means that the model has also seen the last 4 points that we kept apart. So now the model knows all the data. So let's do some forecasting. So model, predict model, and I want to invoke the theta model, final. And now my forecast horizon is going to be, I want to check the next 20 days. Okay. And this column here are the next 20 days after the last date here. All I have to do is create 1 extra column, okay? 1 extra column with the next 20 days forward and attach it to this data frame, this one here. And I have my forecast, okay? James, split the data into train and test set. That's exactly what has been done here in the settings, okay? As you can see, when you include this FH forecast horizon, you are splitting the entire data frame into training and test. Obviously, the test is going to be the last 4 days of the data set. So these 4 days, okay? And the model is going to be trained with the rest of the 494 rows previously. And as you can see that here. So the trained data set is 494, the first 494 values. And the test data set is the last 4 values of the training set. So that's how do we validate all these metrics here. Okay. And we have finished and concluded our forecast. So I gave you 2 methods. The first one with all the chart and everything, 9 lines of code. This pie caret where you can see a ton of model training all at once. All I need is how much after loading the data. We need 1, 2, 3, 4, 5, 6, and 7. 7 lines of code. Not bad, eh? 7 lines of code. Yeah, I know, James. I love PyCaret too. In fact, I love it so much that I'm part of the of the core team of PyCaret, of the developer team. So yeah, that's it, my friends. Any other question? Praveen, insightful and informative. Thank you. Okay, thank you very much. Also, no problem. He has to go to another.
Thank you, Pablo. It was wonderful. I really liked the presentation, and you have a nice style of presenting too. It was good to hear. It's very practical the way you explain, and going to be quite useful for some stock market analysis.
Thank you very much. I have a defect. I've been doing training for many years, so every time I present something to a new audience, I try to be informative and try to explain more or less every step how everything is done, so people can understand. I don't know if the audience is experienced or not into this particular topic, so I try to make it in a way that that most of the people can understand as much as possible. Yeah.
Brilliant. Yeah, I look forward to talk to you again, Pablo. Thank you so much. Thank you, Jonathan. All right, everybody.
Yeah, Praveen, I'll make that happen. I'll create that.
Awesome.
Make that happen.
Awesome.
I just want to say Pablo is being very humble. He's actually a professor in AI. He has written a couple of books and is writing some more. So yeah, so that's why we are enjoying the class tutorial, the webinar rather. So we look forward to more.
Okay.
All right. Thank you.
Thank you, Praveen. There is a nice question here by John. He says, how do you know if the model is overfitting? Well, overfitting is very usual in time series. All you can do is evaluate the behavior of the model and compare it against the actual values. So you can see that it is not necessarily overfitting. Overfitting is not always a bad thing necessarily, okay? So the model can actually identify a good pattern and expand it. So that is a good predictor, good estimator, but that doesn't need to be necessarily overfitting. But overfitting is more related to regression and classification. Time series, sometimes, but time series has a different approach. And in here, for example, we can see that the model is imitating the values of the actual data, but it's not exactly fitting perfectly into that. So we cannot assume in this scenario, in this particular one, I'm not talking any other, that maybe overfitting is not happening. So yes, we can try definitely Picaret on inflation. All you have to do is just load the data. You can do it yourself, no problem. All you have to do is tell the setup and the algorithm that this seasonal period, instead of being capital B, is a yearly data. That's all you have to do. That's all you have to do. Just carry over and do exactly the same thing that we have done here. So that's all the change. James, so I'm just answering your question. Good stuff. Good stuff. Thank you very much. Thank you for the clappings. Okay, I'm gonna save this, and I will definitely, Jonathan, I will share it with you. So if you want to share those notebooks with your audience, your people, your students, or the audience from Summit Africa, definitely you can do that. Excellent. Okay. So let me start sharing here. Back to the screen.
This was really fast. Was anybody writing the code alongside?
Well, as I said, it took me just 10 minutes for each. So, and I was slow because I was explaining as well as I go. So yeah, but it was, I said, fast and furious. No, I'm not furious, by the way. So
I think it was quite insightful. I've not really had much experience with time series, but I think it was interesting, and can start thinking of ways to implement them. The inflation broke our hearts.
Me too. And I'm sorry for you, but it may not happen. Don't be surprised. But I'm just saying that all you're seeing when you see a forecast is what the model is doing is extrapolating the historical patterns forward in time. That's all. But that doesn't mean that this is exactly what is going to happen. That's a prediction. This is what the shamans and the wizards do. But we're not shamans. We are just statistician people just doing a statistical inference with a model. That's all we are doing. So it may happen, it may not happen. But if nothing changes and everything remains, this is what we can expect. The most likely thing that we can expect. but not what we are going to expect for sure. Exactly. We are using a history to forecast future. Yes, exactly. This is a Bayesian approach, not always the same. Nobody could ever expect what the impact of pandemic was going to be.
Say that just now.
And all forecasts happening during pandemic, you can put it all in the bin. Nothing works because that scenario was never anticipated.
Yeah, sure.
Yep.
Thank you very much for the time well spent. The session will be shared soon. Okay. James is asking a question. John is asking a question. Okay. Okay. Okay, that's my question.
Well, yeah. Well, talk to Mark Zuckerberg. Maybe he's happy or not with the name of the package, but or maybe Jan LeCun, which is the guy who actually developed it. So.
All right. Thank you very much. It's been an amazing session.
Likewise.
We're very glad to have you. We look forward to more of these sessions.
Absolutely,
And,
anytime.
I'm happy to let the guys on the call. I think majority of the guys on the call here are with us in Zoom meets. In fact, everyone presently, and we're working with Pablo. He's going to provide us with industry related questions for data wrangle, real world simulation. That makes you think on your toes, that makes you feel like you're actually working in an organization. Those are the kind of questions that we're preparing for data wrangle. So we look forward to launching that and starting testing with both us in Zoomit and some of our past interns and students. Thank you very much, Pablo.
Pleasure, guys. Thank you very much.
Thanks for Pablo.
Have a great day.
Oh, Pablo, they're asking you to come again for another session.
Yeah, it's all in the hands of Jonathan and Summit Africa. I'm happy to come over. So of course.
All right. Thank you very much. So have a very good evening.
You too. You too. Thank you.
Bye.
Bye.
Thanks, guys. We'll enjoy the rest of the evening.